Hello class, this is Mrs. Klusek. I'm going to try to explain to you how to graph a sine wave right now. All right, we're going to start with looking actually at the unit circle in our radian graph paper, and we're going to look at quadrant 1. We're going to see that we start at this point, which is 0, 0, and then we travel up to x in radians of pi over 2, 0, 1. So again, starting at 0, 0, and I'm traveling up to pi over 2, which goes to a y value of 1. Now I'm going to switch colors and do the next section of the graph. You don't have to do this for your normal parent function, but I'm trying to explain what was happening here with these colors. So now we're going from pi over 2 to pi on the x-axis, and then we're going to go to a y value that corresponds to the number 0. So at pi is going to go to 0. Okay, then the next section of the graph is in orange. That's in quadrant 3. We're going from pi to 3 pi over 2, and then we're going to get a y value of -1 there. So we're going to dip down lower here into this one down here. And then the last section of our graph is going to be quadrant 4, which is from 3 pi over 2 back up to 0. And we're going to have a 0 value there. Actually, this is 2 pi, right? Full circle rotation, 2 pi. Okay, and obviously you don't need to make this multicolored wave. You can see I've graphed that here. This is called the parent function. But we have an amplitude change now, an amplitude change of 2. So what's going to happen is I'm going to multiply all of these values, their y's, by 2. 0 times 2 is going to be 0. Then I'm going to multiply this one to take it up to 2. I multiply by 2. Anything times 0 stays the same. The -1 gets multiplied by 2. So you can see this is a change in the amplitude. Now I don't, again, need to use all these colors. This is a sine wave, so it needs to be wavy. All right, now I have an amplitude change of 1/2. Now you notice I've changed the scale on my y-axis to scale by 1/2, so you can see this. So my original parent function that's going to go up to 1, hitting these zeros down to -1, is going to look like it's steeper, but it's only because I changed the scale on my y-axis. So again, 0 times 1/2 is just 0. And then at pi over 2, it's at 1, so it's going to be at 1/2, so it's going to be more narrow. Okay, but the parent function is higher, and then this amplitude change is the skinnier one. I could have kept scaling by 1s like here and just gone in a real skinny little wave underneath that if I didn't want to change the y-axis. All right, last example, I'm taking and looking at negative sine of theta, so I need to go in the reverse way. Notice my parent function, which is your basic sine wave. I already graphed it to save a little bit of time so my video is not so long. And what I'm going to do is take these peaks and valleys and make them go the opposite direction, because I'm like inverting it by multiplying by -1. So instead of going up first, we're going to go down. Again, we're going to hit those zeros, and then we're going to go the reverse way. This is just the answer. Don't need to switch into 4 colors. And again, please make your graphs wavy. It's not connect the dots. It's not absolute value. It must be a sine wave.